that on my YouTube page. Okay, so today's lecture is all about eigenvalues and eigenvectors, and I hope you know what are eigenvalues. You might have studied that in linear algebra course. So in today's lecture, we'll be talking about numerical methods for finding highest, smallest, relative eigenvalues. Okay, you should know what are eigenvalues and what are eigenvectors and what are their implications. Usually we use eigenvalues to check the stability of a system. You have designed a machine, you have designed any system, you have modeled any system, and you want to check its stability. For that purpose, what do? We usually use eigenvalues and eigenvectors. Okay? You must be aware of it that if you have a matrix of order 2 cross 2, there will be two eigenvalues. If a matrix is of order 3 cross 3, there would be three eigenvalues. They might be different, there might be two of them may be equal, three of them may be equal, they might be complex as well. Right? Generally, if a matrix is of order n cross n, there will be n eigenvalues. Okay? So as I said, in most of the cases, we are interested in largest eigenvalue to check the stability. Sometimes we may be interested in smallest eigenvalue. Okay. Or sometimes we may be interested in the eigenvalue near to a specific number. That's what we call usually a relative eigenvalue. Okay, and if you have a matrix of order, let's suppose 100 by 100, you will be finding 100 eigenvalues. And then you'll be looking for the largest eigenvalue in those 100 eigenvalues. Okay, so, and the same thing for smallest as well. If we have a matrix of order 2 cross 2, the characteristic equation for that matrix will be a degree 2 equation, a polynomial equation of degree 2, which obviously is easy to solve using quadratic formula. If a matrix order is 3 cross 3, again, the degree of characteristic polynomial would be 3, which is a little bit hard to solve because you need to guess one root and then you will be using synthetic division to find the other roots. As you increase the order of a matrix, the degree of characteristic polynomial will be increasing. Okay? And that would basically cause what? That will increase the computational cost. That will increase the method to find क्या कहते हैं इसको उसकी जो computational cost है that will be obviously increased. Okay? And if you are interested in all the eigenvalues, then it's okay, you have to do that in any mean. But if you are interested only in one eigenvalue, that's either largest, smallest, or any relative, why would you compute all the eigenvalues? So for that purpose, what do? We use numerical methods to find largest eigenvalue or smallest eigenvalue, or maybe relative eigenvalue. So you know the definition of eigenvalue? Usually we say for a square matrix A, you'll be looking for a number lambda such that it extends or it increase or decrease or change direction of a non-zero vector, right? For example, if we have a matrix A, okay, and we have a non-zero vector x. We want to have a non-zero vector, right? Because eigenvector can never be zero. So you'll be looking for a non-zero vector x such that you transform that vector by using this matrix A that give you word that only increase or decrease whatever because it's a multiple of that one. So we say Ax that should be same as lambda x. Okay? If that is this equation is whole, what happens? We say lambda will be the eigenvalue, whereas x is the eigenvector. Okay, and you need to solve this system of equation. Obviously, the system of equation. This might be written in this form. If you want to write, you find the value of lambda and x both. So for that purpose, what do? We simply right? This equation is ax minus lambda x, to make it simply a non-homogeneous equation, system of equation. Ax minus lambda x equal to 0. It's a homogeneous system of equations. This could be written in the form, if you take x common out of it, so we can write that as a minus lambda I. Keeping in mind A is a matrix, so you should have I with lambda as well. So we'll be having A minus lambda I into that vector x, which is equal to 0, right? Now this is a homogeneous system of equation, right? And for homogeneous system of equation, as I said earlier, we are looking for x not equal to 0. It means we will be finding a non-trivial solution of this system of equation. Okay, but non-trivial solution for a system of equation exists if, what is the condition? If determinant of the coefficient matrix is what? That is 0. Because if determinant of the coefficient matrix is not 0, then the system will be having unique solution, and in that case, you'll be having only trivial solution. We are not interested in trivial solution. We are interested in non-trivial solution. So that's why we take what? We should take this determinant of a minus lambda I to be 0. Okay, and that will give you what? That will give you obviously a characteristic equation. Then you just need to solve this characteristic equation to find the values of lambda. And these lambda will be representing what? These lambda will be representing the eigenvalues. Then putting this value of lambda in this equation, you get homogeneous system of equation, which you would solve by using either Gauss elimination or whatever Gauss Jordan, whichever method you like, you can use for solving this one. Okay, and that will give you what? That will give you eigenvector. Obviously, the system will be having many solutions, because in case of non-trivial, there will be many solutions. Okay, so you see this equation, this is known as a characteristic equation that is obtained by this method what we have here. Is that clear? Okay, but our interest, as I said, that is in simply in numerical methods for solution of that problems or for finding largest eigenvalue. We use the method which is known as power method. Okay, so in power method, what do we do? You will be simply selecting a non-zero vector of your choice if it is not given. But keeping in mind that you would choose what? A non-zero vector. Okay. And then what do we do? Let's suppose that non-zero vector is what? That is, let's suppose that we want to find largest eigenvalue of matrix A. We take a non-zero vector and let's suppose or let label that with x0, which could be 111, which could be 101, which could be 100, which could be 001, any vector of integer. Right? Usually we take 111 if it is not mentioned. If it is mentioned, then obviously you don't need to change that. Now, what would you do? The process is very simple, very straightforward and very simple to find the largest eigenvalue. Okay? How do we do that? You see, you are given x0. You need to understand power method. The rest, there are two other methods as well. One is inverse power method and the other one is shifted inverse power method. Once you understand power method, the remaining two methods are very simple and very straightforward, because we'll be using the same power method in those methods as well. So in step one, what would you do? You would simply compute product of A, which is the given matrix, whichever order it is. That should be a square matrix, obviously, because you can find eigenvalues and eigenvectors of a square matrix. Okay. So if you multiply this x0 with the A, keeping in mind if A is of order, let's suppose 3 cross 3, then x0 should be of order 3 cross 1. Otherwise, multiplication is not possible. And that's obvious because, yeah. So once you multiply A with x0, you will be getting another vector. And we label that vector as, let's suppose that is y, or maybe z or something, y of 1. Is that right? You can multiply them, ax0, that is equal to y1. You just label it, because you'll be getting another vector. When you multiply a 3 cross 3 matrix with 3 cross 1 matrix, what will you have? You will be having 3 cross 1 matrix, which is obviously a vector. Now, the next step, what would you do? You will be finding norm of this y1, and that will be the infinity norm. Which one? Infinity norm, right? I hope you remember what is infinity norm. I told you at that moment that we are not going to do with norms, but we'll be using that. So we used norm in the convergence of Gauss, Seidel, and Jacobian method, and we are using infinity norm here as well. Okay. Now, what do we do? That basically means you have to pick the absolute largest value in that vector. Infinity norm is like that. And we label that as, let's suppose that's my mu1. That's my first approximation towards my largest eigenvalue, lambda. Okay. Once you have done that, now you will be finding corresponding eigenvector as well. The corresponding eigenvector will be found as, let's label that as x1. And x1 is what? You simply normalize this vector by dividing y1 with this mu1. Okay. I hope you see there. Right? Okay. So you normalize this vector and call it now the next iterative value of the eigenvector, that is x1. Okay. So this is one operation. This approximate largest eigenvalue is mu1, and the corresponding eigenvector is what? That is x1. Now you would repeat this process again. You will be finding now what? You will be finding y2 now. Okay, so it's y2, which will be again multiplying this x1 with a now. So multiply x1 with a, you'll be getting y2. In the next step, what would you do? You would again find mu2, which will be the infinity norm of now y2. That's the infinity norm of y2. Right? So this is another approximation towards larger. That's an improvement, obviously. It will be improvement. And then we again the corresponding eigenvector, which is x2 now, and the procedure will go on and on unless you converge to the largest eigenvalue. X2 will be what? That is simply normalizing this y2 vector now, the y2, and then we have what? Divided by mu2. And so on. I hope you understood the method, you got the idea, didn't you? So that will be converging towards what? At the end, if you have done k iterations, so you'll be saying that lambda is basically what? The largest eigenvalue. If you call it, let's suppose lambda L, the largest eigenvalue. So that will be what? That will be mu k if you have done k iterations. So this will be the largest eigenvalue. Okay. Obviously, if you are doing 5, 6, 7 iterations, so it will be correct up to maybe 2 dp, 3 dp, 4 dp, or 5 dp. Is it clear? Any question up to here? If there is no question, so then let me get rid of this. You have written it or not? Okay. So should I clear it? Right. So that's what the process is altogether. That's all you have to do. Okay. You see, we are doing what? We are simply multiplying A with ZK. Your ZK will be obviously changing Z1, Z2, Z3, or so on. And then we find Y. Then we take the infinity norm of that vector Y to get this value. And then at the end, you normalize the vector, you scale the vector to get next eigenvector. Okay, that's the way to do it. Okay, let's do an example. We need to use power method to find dominant or largest eigenvalue of this matrix A, which is given by 10, 2, 7, 1, 1, 1, minus 1, 1, and minus 3, right? By initializing the value with 3, 1, 1, T, that means transpose of this one, right? Right? It means transpose. Because we'll be needing a, vector, a column vector, because multiply with this, with 3 cross 3, we need 3 cross 1. So you may write that in 3, 1, 1 transpose, or you may write this in a column form 3, 1, 1. Okay, it's up to you. Now what do we do? It's already done. So simply multiply this matrix with this vector first. So what do we have? You see 10 into 3 plus 2 into 1 plus 7 into 1. That will give you 39. Okay. The second row with first column, that would give you what? It will give you 3 plus 1 plus 1, that is 5. That's basically y1. Don't be confused with 1y, 1z or something like that. This is y1 basically. Okay. And the other one is obviously z1, that will be the first approximation towards eigenvector. Okay, so in this case you see, and the third one is giving you what? Minus 3 plus 1 and minus 3, which give you minus 1. So that's the first product, okay? This is the product of vector matrix A with this vector, which is 39, 5, and minus 5. Now, what is the largest value? 39. So, mu1 in this case will be what? That will be 39. Okay? And then you divide this vector with 39 as a whole to give you 1.1282 minus 0.1282 to get a corresponding eigenvector. So, that completes one iteration. Okay? And in next iteration, what would you do? You would multiply now this vector with this matrix. Okay, to get this one, again the largest value is what? That is 9. Okay, dividing this by 9, what would have 1, 0, 0, 0. So this is the next iteration eigenvalue, next approximation for eigenvalue, whereas this one is what? That's the corresponding eigenvector. Right? So you see that at the end we are approaching towards what? It's 9.7302, 9.7194. Okay? It means it's correct up to now almost 2 decimal places. If you have ability, if you can do this thing in exams by using calculator, multiplication and accuracy calculator, you are allowed to do that. You don't need to do these things manually. But you must be able to do that. Can you do that? Should I try one for you? You should remember this this matrix. Yeah, it is there. So what would you do? You would first go to the matrix mode. Do you see it properly? You should practice yourself. I'm trying here, and you should practice yourself. I'm unable to increase the size of the calculator. I hope you see that, right? Okay, so simply press the mode, and then you see that at the 6th number, there is a matrix mode in the calculator. It could be at any position. It depends upon the model of your calculator. Okay. So I'll be simply clicking on 6. Now I'm in a matrix mode, and they are asking that which matrix do you want to label. So I may label matrix A for this matrix. Okay. So that is what that lies at 1. So you'll press 1. Okay. Now what is the order of this matrix? You need to define that 3 cross 3. So you will be simply click on 1 to get 3 cross 3 matrix. Okay. I hope you see that properly. Right. Now the first value is 10. You can simply type 10 and then equal. In your case, I might use enter because I'm doing it on computer. And the next value is 1. So you simply type 2 from here and then you press equal. Okay. Then you press 7. The next value is 7, obviously. Okay. And then you press equal. The next value is 1. You press equal, next value is also 1, you press equal, next value is 1, you press equal, then we have minus 1, it's minus 1, and then press equal, then we have 1 again, press equal, and then we have minus 3. You can do directly or you can simply use that negative sign as well, right? So we have minus and then we have 3. 7, 3, sorry, equal. So we have this matrix. I presume I have written right numbers. The first number is 10, the second is 2, 7, 1, 1, 1, minus 1, 1, and minus 3. That's right. Okay, so we have this matrix now. Now what do we do? Simple press AC to clear the screen and then go for another matrix. And for that purpose, what do you do? Just go for shift and you go for 4, right? And we want to have another matrix B. So let's press 4 again. Sorry, I made a big mistake on that. We need to go for another matrix. Okay, and that was where? And then we go for 6. Okay, and then let's go for 2. And we need to have 3 cross 1 matrix. So I have press 3 now. And I would give this initial value 3, 1, 1. It could be anything. Let's do that. 3 equal, sorry, let's make it 3, and then we have 1. I'm presuming that you do same thing. If I make any mistake, you should correct that. Okay, so we are having now this value. Okay, what would you do now? Up to this step, it's easy, obviously, because you just input the matrix. So again, clear this one, and now I go to shift, because I would multiply matrix A with matrix B now, right? So I just go to shift and then press 4. You would see there is a matrix here, right? You see matrix. So you just go for matrix. Right. Now what do? We want to multiply A, so we simply take 3, right? And then we do multiplication with, again go for the same setup, and we'll go for 4, and we want to multiply that with the B, the matrix B. Now we press equal. I hope it's okay. It should be okay. Why not? Why am I doing wrong? What is wrong? You got that? But why am I not getting it? What's wrong with me? This should be there. Anyway, let me do it again then. It is not there, so I will do it again. You need to clear the computer as well, because sometimes you have memory in it. So let me do that. Just to clear it. How do we clear it? You know? Okay, let's just do that again, right? I basically have, I think, change the thing. So we are in matrix mode. So go for, let's go for 6, having matrix A. Then we have 3 plus 3 matrix. We have 10. Next one is 2. Next one is 7. Then it's 1, 1, 1. And minus 1. Then 1 and minus 2. Okay, we have done that. So let's clear it now. And let's have another matrix. And then we have matrix B. Then we have 3 plus 1. Then we have 3, 1, and 1. Okay, and then okay, this one. So let's do that. Shift and then matrix. So I want to multiply 3 with matrix B, which is at 4. Still giving error. You're getting that? Then why am I making error? Where did I make error? I basically want to show how to do these iterations directly. You don't need to do that again and again. So Please select the matrices from the wrong way. Okay, let's do this. Why am I making an error? I should have done that. So we go to setup and then we go for matrix 6. Okay, and then let's suppose we go for 1. We want to have matrix 1, 2 plus 3, which is 10. And then I'm having 2, I'm having 7, then I have 1, 1, 1, minus 1, 1, and then minus 3. Okay, and then go for another matrix. Where can I go from this direction? Two again. Then I have 3 plus 3. Then I have 3, 1, 1. 3 is okay. Okay, let's do this again now. So it's 3 multiplied by 4. Yeah, it's okay now. I'm just making the wrong, going in the wrong direction. Now, what do you see? We are having 39, the largest value, okay? You can check that which one is largest. So it's 39, the next is 5, the next is minus 5. So the largest value is what? That is 39. So what would you? You simply divide this matrix by 39. You should know 39 because that will give you 1. Okay, now how would you do, which matrix would you divide by 39? Basically, this matrix is stored in what? You see, if you go back to 4, there is a mat ans, right? Mat ans. So basically, this product is saved in where? In mat ans. So you'll be doing what? You simply take 6 and divide that by what? By the largest value, which was 39. Okay, that's equal. So we're having this one. You see, we'll be getting same thing what we have here. Again, this matrix is saved in where? In mat ans. So next time, what will you do? You would simply take again for the second step. Okay, you will take again shift and then 4, and then we have matrix A, right? Multiplied by. Now next time we will multiply by what? Will be multiplied by mat ans. That is number 6. So multiplied by 6. Okay, and then press equal, you will be getting the next iteration. You see 9.3590 and so on up to so many iteration. Sorry, so many decimal places, significant figures. Okay, and then you will be looking for largest value. If you don't see largest value, you just you can move downward and so on. See, now the largest value is what? 9 in this case, obviously. So you'll be dividing what? 9 point something. You should note this number that it is 9 point something. Right? So next time, what will you do? You would simply take the mat ans, okay, 6, and divide it by what? That is 9.3590, whatever it is, it will be written as 9.35. It was 89, right? 89 something, 1 or kuch there was something. And then you equate that, okay? So again, this is now. You see, it's almost 1.0 because we have taken up. You can fix that. You can fix that up to 3 decimal places, 4 decimal places, right? Doesn't matter. It should be 1. Now, next time, what do we do? You go back and then you go 4 and take the 3. That's the matrix A. Okay. And then multiplied by, again, shift with 4 and multiplied by what? 6, which is mat answer. And that will give you the next value. It is 9.8493 something. Right? You will be repeating this process again and again. We don't need to do this multiplication manually. That was the advantage I was trying to show it to you. So I think it's easy. You should do maybe, if it is not mentioned, you should do up to 6 or 7 applications. If it is mentioned, then you have to do that many applications. And you can use obviously calculator to do that in exam. Directly, simple multiplication is that and that and that. So at the end, we basically reach to which number? We are reaching towards 9.7194, right? That is the largest eigenvalue, whereas this is the corresponding eigenvector, right? So let's clear this. Okay, so the next, you should do some examples by yourself just to practice it. We have done that, and you have found these values as well. Now we move towards inverse power method. Now this method is used for finding smallest eigenvalue. Okay, this method is used for what? For finding smallest eigenvalue. So that's the first statement. The method is used to find smallest eigenvalue of a given square matrix A, right? And in that case, what do we do? If I go back and I just explain it to you, you should know that if lambda is the smallest eigenvalue, if lambda is a small eigenvalue of matrix A with corresponding eigenvector, which is x, that means we would be writing this equation as Ax is equal to lambda x, where lambda is the smallest eigenvalue of what? Of matrix A. Can we write this equation in the form, if I multiply this with A inverse and divide by lambda, so we may write this as A inverse x equals 1 over lambda x. I hope it's clear to everybody. Simple manipulation is there. So it's A inverse x, that is equal to 1 over lambda x. What does it mean? It means 1 over lambda is the eigenvalue of what? 1 over lambda is the eigenvalue of A inverse. Okay, that's A inverse. And that will be the largest eigenvalue. Because lambda is the smallest eigenvalue of A, so 1 over lambda will be the largest eigenvalue of A. Okay? So this will be largest. Now you see that what would we do? We will be simply finding largest eigenvalue of matrix A inverse. In other words, we would apply power method on A inverse. Right? We'll be applying power method on A inverse. The rest is straightforward, the same. The only thing, the extra step we'll be doing, that is what? That is finding inverse of the matrix of the picture. And at the end, you will get what? You will get simply 1 by lambda, which is the largest eigenvalue of what in terms of A inverse. So that will be something like mu k. Because we are getting basically mu k at the k iteration. So 1 by lambda will be mu k. But we are interested in what? We are interested in lambda. So lambda in this case would become what? That will be simply 1 by mu k. So lambda is equal to 1 divided by mu k. Is it clear? Okay, that's good. Do you know how to find inverse of a matrix using calculator? Exactly doing the same thing. Just read matrix in calculator and then take the negative power, the minus power. Right? So let me get rid of this, right? We have done right. So, yeah, that's a complete process. I explained. Okay. If lambda is the smallest eigenvalue of A, in that case, you see the eigenvector remain the same. Because in the first case we had Ax equal to lambda x, and then we have A inverse x is equal to 1 over lambda x. So x is fixed. It means eigenvalue will remain the same, eigenvector will remain the same. The eigenvalue will be reciprocal of each other, but eigenvectors will be same. Okay. And if lambda is the smallest one, 1 over lambda will be the largest one. So what would you do? You would simply find inverse of the matrix first. And then in these steps, what they did basically, they are solving this system, because when you have A inverse into Z, K is equal to Y, it could be written as AY is equal to Z, and then you can solve the system of equation for Y. But otherwise, you can simply do that as well, that Y is equal to A inverse Z, and then repeating the same steps. Right? The same step means you will multiply A inverse with X naught to get Y1, right? Then pick the absolute infinity norm, right? Divide that vector y by that norm, mu 1, you will be getting what? A scale, a normalized vector. And then you do what? You multiply that normalized vector with A inverse again. Is that right? Okay, that's good. So if you want to do this, the same example we have done a bit earlier, you need to use inverse power method. If it is not mentioned to use inverse power method, you have to use inverse power method to find the smallest eigenvalue, right? And the process is same. If you multiply this, the inverse of this matrix. So first you need to find inverse of this matrix. Okay. How do you find it? Should I do it for you? Okay, so it is again, let me open okay, so let me try this first. Let me show that example. So we have a matrix in front of us. This one as well. So right. So again, you will be going for matrix. So that is. Let me try directly if I have that matrix still in this memory. So shift and then 4 and match A for 3, and I will take inverse of it and then equate that. Yeah, you still have that. Okay. So this is the A inverse. Now you should note these entries because you have to redefine matrix A. This will be stored in ANS math, but ANS math will be changing when you do product, right? And we need to have A inverse to be fixed. You should note this matrix if you have found there. Have you found that? You defined inverse. Because this matrix will be saved as what? Is ANS, mat ANS. Okay. So, and the product is also saved, will be saved over there. So in that case, this matrix will be overwritten, and then next time we may not have this. We need to convert these entries into what? Into another matrix A. If you have done that, so I'm just switching to matrix A to find matrix A. Because you have to tell me the numbers. Okay, so let's go back to that matrix 4 and then talk about the data, which is 2. And then again, I'm taking matrix A for F1. Okay, now you have to change the values because that's the old matrix also there, still there. So, yeah, what is the first value? It was in fraction as well, you can see that. Okay, 0.1818. Okay, that's right. Next one is that's 0.9090. Okay, minus 0.09. Okay, next value. Next value. tell me the next value, come on. Okay. So in this case, you see, right, that you will be simply finding the inverse. Then instead of matrix A, you'll replace those values by what? By A inverse entries, and then multiplying it with this matrix. First time it will be saved in mat ans. Next time we're multiplying mat A with mat ans, and you repeat this process again and again. So you will be having what? You will be having this eigenvector after 7 iterations, right? And the eigenvalue will be this one. But that's the largest eigenvalue of A inverse. We need to find smallest eigenvalue of this one. So what do we do? We simply divide this number by 1. It is 1.1467, right? And then we take inverse of this number to get the smallest eigenvalue. So the smallest eigenvalue will be what? That is 0.8720 if you do multiplication, right? You didn't tell me the right entry, so I just left it to you. You should do that. Any question here? Right. So let's move to the next one. That is a shifted inverse power method. This method is used to find an eigenvalue near to a number, relative to a number. Okay. So let's suppose we are interested to find an eigenvalue nearest to a number gamma. Okay. For that purpose, what do we do? Lambda minus gamma will be the smallest eigenvalue of what? You see, let me do that. You see, if lambda is the eigenvalue which is close to gamma, so we will be having Ax is equal to lambda x. We say lambda is an eigenvalue of what? Of that matrix A which is close to gamma. Right? Can we write in this form if I subtract gamma x from both sides? So we have Ax minus gamma x, that is equal to lambda x minus gamma x, subtracting gamma x from both sides. We can do that, right? And then what do we have on the left side? We'll be having A minus gamma I into x equals lambda minus gamma x. What does it mean? It means lambda minus gamma is the eigenvalue of A minus gamma I, isn't it? If you call this matrix as B, so you say lambda minus gamma is the which eigenvalue? Will it not be the smallest eigenvalue? Because lambda is very close to gamma, so the difference between lambda and gamma, that will be the smallest. It means lambda minus gamma is the smallest eigenvalue of what? If you call this matrix B, whatever, which is equal to A minus gamma I. Right? This is A minus gamma I. Now, we are interested to find smallest eigenvalue of B now. So which method would we use? We'll be using inverse power method. Because for smallest eigenvalue, we are doing what? We are using inverse power method. Mean to say, you will be finding B inverse first, and obviously you'll be finding B first, then you would find its inverse. Okay, multiplying this B inverse with what? Multiplying B inverse with that initial value of x naught, because eigenvalue remain the same. Eigenvector, sorry. X is here, and the same x is here, same x is here. So it means the eigenvector will remain same, the eigenvalue will be obviously changing. So B inverse into x naught, we call this what? We call this, the process is now same, we call it y1. Okay, and then we find infinity norm of this vector and call that mu1. So mu1 will be what? It will be simply norm of infinity norm of y1. And then you normalize y1 to get x1. The rest steps are same what we had in power method. Okay. Once you are done, if you have found this mu k in the kth iteration, okay, so mu k is basically what? Is it not the smallest largest eigenvalue of B inverse, which would be 1 divided by lambda minus gamma? Am I right? Am I clear? Because you see, lambda minus gamma is the smallest eigenvalue of B, which is A minus gamma I, right? So 1 over lambda minus gamma will be the largest eigenvalue of what? Of matrix B inverse, which is A minus gamma I. But we are interested in what? We are interested in lambda, because we want to find lambda. So can we write in this case, lambda is what? I hope you could solve this. Lambda is equal to 1 over mu k plus gamma. Okay, mu k plus gamma. So that will be the eigenvalue which will be close to gamma. Is that right? Any question? So the only thing you will be doing that is what? That is finding B first. And how do you find this in shortest way? You will be subtracting the number with which you are finding your closer eigenvalue from the diagonal entries. Subtract that gamma from the diagonal entries of the given matrix, you will be getting B. Then find B inverse by using what? By using calculator, and then use those entries, multiply them, and that will be getting what? An eigenvalue which is close to that number. Okay, so yeah, that is simple. You have done that. So that's the complete process. You see xj is equal to lambda j xj, which is the eigenvalue close to a number gamma. Then we have this setup, as I explained earlier, the subtracting gamma xj on both sides. And then we have this one. So this is the largest eigenvalue of this inverse. Okay. You do same, these are the steps, the same steps what we had in case of power method. The only difference is you will be multiplying with B inverse now. And at the end, we do what? As I said, we'll be taking this one is largest eigenvalue. If it's reciprocal, we give you what? Smallest eigenvalue, and then you add gamma with it to get an eigenvalue close to gamma. Right. This is an example, what we have done a bit earlier. So you see, that is A. We want to find its eigenvalue close to -2. It means you will be subtracting -2 from the diagonal entries. The matrix B would be what? 10 minus -2. It will be 12. 1 minus -2. 3, and -3 minus -2, that is -1. And then you find inverse of this matrix first by using calculator, and then you will be storing matrix A like this. Multiplying this with, again we take same 3, 1, 1 transpose, so you can do the same. These are the total iterations. You see at the end what to have. This is the largest value, absolute largest obviously. So we'll be simply taking reciprocal of this number, okay, and then adding -2 to it, you get -2.5 5940. It's obviously an eigenvalue close to -2, and that is a corresponding eigenvector. Is it clear?